So David is joining us. He's going to talk a bunch about Rust and Lambda and Rust Runtime. And I have been joking behind the scenes. I'm excited for this because I've been following David for a while on my Rust journey in the last 6 or 7 months. So super excited to hear him talk. And he's a maintainer on a couple of really key projects. So the floor is yours, David.
Thank you, Ben. Uh, yeah, let me start mentioning this because not many people know, and sometimes there is some confusion. Uh, I'm a senior engineer manager at AWS, but I work on AWS Amplify. I don't work on AWS Lambda. Uh, so everything that we're going to cover today is are things that you can find online. I don't have any really special knowledge about AWS Lambda. So everything that we're going to cover today is basically what's in the public documentation, but people have been doing for a long time in the community. Um, and as a fun fact, I came up to be the maintainer of the Rust Runtime the first day that I joined AWS because I had contributed in the past. I actually created my own fork uh, for the Rust Runtime for Lambda. Uh, and when I joined AWS, they were like, "Oh, you're here now, so now you're the maintainer of the Rust Runtime for Lambda." It's like, cool. So I've been doing that for the last 2 years at night on my own time, and during the day, I'm a manager for AWS Amplitude. So let me share my screen and we can start. I barely use Zoom, so this is gonna take me a second. Where do you think to share my screen?
All
There
should be
should
down on
be
the
a,
bottom.
a green button.
There it is, share screen. I'm gonna share my whole screen because we're gonna go through documentation. We're gonna jump to
Awesome.
my code editor and whatnot. So I just wanna be able to share everything. I'm gonna minimize this window, so I'm not gonna see you anymore. So feel free to shout out if you have questions. You can interrupt me. I'm not gonna see you, so like don't try to raise your hands or make any movements because are gonna mean nothing to me. Uh, uh, Let me this gonna share here. All right. I'm gonna start with a very basic introduction. Let me just, sorry, I have my notes in another computer. I just want to sleep. I'll wake it up. There it is. All right, I'm going to start with a very quick introduction of what AWS Lambda is. I'm pretty sure you all know what it is, but just in case, AWS Lambda is a compute service that allows you to run code without provisioning or managing servers. Right, so very straightforward description. Um, uh, when it becomes tricky is when you start diving deep into what that means. So, like for example, it lets you run code. So the first question that people have is like, well, in which programming language? Right? Which is a very valid question. So if you go to the Lambda documentation, you'll see that it says supported languages as Node, Python, Java, .NET, Ruby, and then we have operating system only runtimes. Right? So as you can see, there is no Rust supported runtime. But we're here to talk about the Rust runtime for Lambda. Right? In 2018, there was this announcement, Rust runtime for AWS Lambda. And as you can see in the announcement, it's basically saying that AWS Lambda now supports Rust as a programming language to use on Lambda, right? And again, like if we go back to the documentation, it doesn't really specify that you can use Rust, right? And there is always that confusion when people are like, well, you can use Rust, but it's not supported. So how do you do it? What's going on here? So at the same time that Lambda announced this support for the Rust runtime, what they also announced was the extensibility model for Lambda, right? Um, this is Lambda extensions, but I really like this graph because it really represents everything that that Lambda does to run your code, right? And it explains how your code is going to interact with Lambda. And this applies to the runtimes that we have here in this list. And it also applies to runtimes that are not listed in here, right? So the way that they made a Rust runtime work was basically by exposing some internal APIs in Lambda that in reality any programming language can hook into. So you can build any runtime that you want. You don't have to wait for AWS Lambda to list supported runtimes here. You can just create your own runtimes as long as they can use these APIs that are described here. You can just basically run anything you want, right? And that's how the Rust runtime really works. It just uses these APIs to control the execution model. And we will dive into this in a few minutes. But I really like this graph. I think this is the best graph that they have, and to represent this. And I'll go into details and a few special things that the Rust runtime does additionally to what is described here that I believe no other runtime currently does. All right. So did say that I guess no one has questions, but again, like if you have any questions, feel free to interrupt me. I want to make sure that this can be also as interactive as it can be for anyone. So feel free to ask questions. All right. So the Rust runtime for Lambda lives in this repository in the AWS Labs organization. So it's called AWS Lambda Rust runtime. The name of the repository is a little bit obsolete, I would say, because this repository includes much more than just the Rust runtime. It also includes code to be able to create Lambda extensions. And it also includes statically generated types to receive events from Lambda. And we'll discover how we transform events coming from Lambda in these types later. But I want to mention that even though the repository is called AWS Lambda Rust Runtime, there are many other things in here, and we also have this Lambda HCP adapter. We'll cover that later. But there is much more than just the runtime itself, and we have a lot of examples, which to me is very important. And we've collected many different examples and people usages. We have a fairly active community that asks questions, and to me, the best way to help them is just to create examples that they can use later to solve their problems, right? So it's a very extensive list of small projects that people can pick up and modify for their needs. And this is one of my favorite parts about this repository, the list of examples. And I use it fairly extensively, and I'm going to show you a couple of examples to demonstrate some of the things that we can do in the Rust runtime that other runtimes don't really implement at the moment. And I think they're fairly unique for that. All right, so I think before we move on, what I'm gonna do is I'm gonna jump to my terminal. I'm gonna start a very quick project just to go through what a Lambda function written in Rust is, and I'm just gonna spend like 30 seconds on it because I'm sure you all have seen it. And I'm gonna use Cargo Lambda, which is a tool that I created also a couple of years ago. And basically, it's an extension for Cargo that allows you to work with Lambda functions easily. It gives you cross compilation. It gives you CLI to deploy to Lambda very easily. I'm gonna call it sample. What is this going to be? We're going to talk about call stars today, so I'm going to call sample call stars. All right, so this should open my editor. There it is. I'm going to make this a little bigger for you all to see. All right, hopefully you can see this font size. If not, just let me know. I can make it a little bit bigger maybe.
Looks good. Yep, perfect.
All right, cool. So really the main structure of the Rust function for Lambda is in this 20 lines of code, approximately. The function handler is the code that you write that receives your events, and then you do something with the event and return something. And then this main function is the code that initializes your code, and it also initializes the runtime for Rust, right? And I think two interesting things to highlight here is it's going to be the service function, which not many people understand what it is and what it's for. And then this run function, which is where we're going to really dive into the details on what the runtime does and how it does it. And just to explain this service function very quickly, the Rust runtime uses a library called Tower to express everything inside the runtime and also to express how we handle the code that you all provide basically in your handlers, right? And what this service function does is that it turns your function handler into a Tower service. Let me just go back to my browser. We have Tower service here open. And basically, the Tower service is an interface that defines how to receive data and how to respond to it in asynchronous functions in Rust. And what this service function is going to do, basically, is going to put a wrapper around your code. And as long as your code is an asynchronous function, which is, it says async here, as long as your function is a sync function, the service function here is just going to put a wrapper around your code to create a Tower service, which is at the end what the runtime executes. And one of the nice things about making applications based in Tower is that, as here says, is modular and it's reusable, right? And by modular, it means that you can plug and play any Tower service that follows this trait, right? So you can extract code from one project, put it in a library, and then reuse it across many projects. As long as it implements the service trait, you can reuse those components, right? And the nice thing about that, for example, here, the Tower ecosystem is very big. So here, I have a Lambda function that is using this Tower HTTP trace library, basically to bring logs when the Lambda function receives an event. It will bring an info log, and before it returns the response to the event, it will bring another log, right? And all this is provided by Tower. We don't have to do anything. Our Lambda function is basically this very basic function that just says success. But because we're using Tower and we're turning the handlers into Tower services, we can use libraries that other people have already written to complement Tower, right? For example, here in this trace layer, you can just, instead of reinventing your own logger, you can just take the trace layer from Tower HTTP and use it, right? And Tower HTTP is a library that has a lot of useful middlewares that you can use in your applications. I definitely recommend you to take a look at it. And then another interesting thing that you can do, and we actually kind of discovered this by coincidence, is that you can also plug bigger applications besides just the small snippets of code that we're seeing here. Besides just your handler, as long as those applications follow the tower service and they implement the tower service tree, you can plug them into the Rust runtime. And in this case, we have an integration with Axiom, which is a very popular web framework in the Rust ecosystem. And what we're doing here is basically we're taking an Axiom app, which receives HTTP requests and returns HTTP responses, and we're plugging it into our Lambda runtime. So as you can see here in this main function, there is no handler per se. The handler is really the Axiom app. So we're declaring a router, which is an Axiom router. We're declaring some routes, and depending on the request path that we receive, we will return whatever these functions return, right? So here we're not declaring any handler. We're not even using the service function call to turn a handler into a tower service, because this router that Axiom provides also implements the tower service. So we can just plug full tower applications into the runtime without basically doing anything, as long as we understand what the application receives and we understand what the application returns. You can basically use, which to me is a very powerful mechanism to expand the capabilities of what you can do with Lambda functions and especially with Rust. And I don't think many other runtimes have the same level of integration that we have with tools in the community. And that's one of the things that I really like about all this work that we've been doing in the last couple of years to integrate with Tower.
So David, real quick, you could integrate that with like a proxy request from API Gateway, right? And essentially just serve anything and take your Axiom app from a container and bring it into a Lambda, and off it goes.
Yep.
That's super cool.
And you don't have to start a server. You don't have to do anything. Just to take your router from another service. if you're using like ACS, or you're using something to handle your Axiom API and you just want to bring it to Lambda, you just declare your router and just pass it to the runtime in this run function, and you're good. You don't have to do anything else. All right. So those are high-level overview of like what you can do with Rust in Lambda, and a few examples on like what are the things that you're writing that you need to do to make it work, right? But I want to dive deep into how this works. I want to go back to this diagram. How does the runtime actually work, and what are the things that we do, and how we do it? I think it's gonna be more interesting for you, because I don't want to go again through the basics on just pure examples. I want to dive deep into this code. And to do that, let me just jump in here. I'm actually going to go back. I'm going to go back here to this run function. Can open it here. Basically, the run function is the start of the runtime. The main function is just going to define what happens in the initialization time for your for the Lambda sandbox, which is what runs your code. So here you can just type whatever you want. You can initialize clients. You can initialize other tools that you're going to need to run your code. But then really the run function is what is going to start the loop that connects to these APIs and makes your code work. So that's what I want to dive into next. And I have here the whole project downloaded. And I'm going to try to go slowly over this. so no one misses anything. So a big disclaimer about how the Rust runtime works is that we use a lot of generics to make things like streaming work, to make things like abstract requests and responses work. There are a lot of generics. So you can ignore them from now. I'm not gonna try to explain every single thing that happens here. But basically we need a lot of genetic traits to be able to return, for example, a streaming response, or to return just a JSON document, because those are two very different concepts. You need a lot of genetic traits. But we have here the run function, and it's really very simple. We have a runtime, and we have some layers. And what we do in the run function is basically just create a new runtime object, and then we run. So this is fairly self-explanatory. And then here run is what really is gonna connect with these Lambda APIs, and it's gonna do all the requests and responses. I'm gonna skip this layer thing. I'm gonna go deep into it later. Hopefully we'll have time for a quick demo about this layering system. I'm just gonna go through what this run actually does. And again, what I was mentioning is that really what the runtime does is that it connects to these APIs that Lambda provides, going back here, and it just requests data from Lambda, and it just responds with what the handler responds. And at the end of the day, that's basically going to be just as we have this incoming stream. And this incoming is basically a stream of requests, incoming requests. So we're sending a next event request to Lambda, which basically you'll see here is defined as next. We scroll them up a little bit. The runtime, and then the Lambda service is the Lambda APIs that provide events. So the runtime basically sends the next request, which is defined here in the code, next request, with this client. And Lambda is going to give you the event that you need to execute your function with next. So it's going to give you the request. And if you send an invocation, your code is going to run, and then it's going to return the response, right? And this is basically an infinite loop. So you receive an invocation from Lambda, or someone else sends an invocation to Lambda, and the runtime is just going to ask for the next invocation. It's going to process it, and it's going to return the response. So what you can see here, we'll go back to this code. Is basically that we have an infinite loop here that it basically says, as long as there are incoming requests from this next API, just process what the next response is, which is going to be a JSON payload, and then do something with it. And we're going to go through each one of those in a second. But at the end of the day, I want to make it clear that it's a very simple event loop where it's just sending requests to the next API, processing the response, turning that response into something that a function handler understands, and then sending the responses. So it's a fairly easy model, fairly easy to understand. And the nice thing about this is like, if you don't like this runtime, or if you want to build your own runtime, again, this is very easy to follow this model. So a couple of other interesting things that we do here. We have context information. Lambda provides a lot of context information besides just the incoming event from the API. So, for example, the configuration for your function, the amount of memory that you have for your function, and if you want to use it. And then we just create this Lambda invocation, which is a wrapper. a wrapper for like the data that Lambda just give us to process the event and this context. And then when the service is ready, which means that the tower service has been initialized and the future for your handler is ready to process the event, we just call with this invocation. So this event loop is fairly simple. You receive the data, you process it, and then you send the data to the Lambda handler, and then return a response. Any questions so far? I think this. And now we're gonna go into the layers, which is gonna explain some of the things that happen in between, which are also very unique to the Rust runtime. So like what happens between here? I'm gonna go here. So when we initialize the runtime internally, basically the runtime is divided into multiple tower services too. So what we do when we initialize the runtime is that we're gonna take your code and then we're gonna wrap several tower services around your code. So the ones that we have here is like we have a catch panic service. So if your code creates a panic, we catch it so we can return an error response to Lambda. And then around that catch panic service, we have a runtime API response service, which is at the end what's going to send the response from your Lambda function to Lambda again. So it can return it to the person that invocated the function. So, and then additionally here, we are also adding a tracing layer, which basically initializes tracing to log in. And here, this code is starting to be a little bit more complicated, but because we're getting into this tower service trait, which you don't really need to know anything about. But since we're diving deep into this code base, I think it's good to understand it. And I'm going to create an example in a few minutes to help you all understand how this works a little bit better. So basically, the runtime API client service, it's the layer that surrounds your handler and your the catch panic. So when the response arrives to it, what it's gonna do is basically it's just gonna send the response to Lambda. Actually, it might be better understand it. Let me just give a second. I think I have. Yeah, we're gonna do some diagrams here. So at the end of the day, you have a handler here. This is gonna be a function, and then what we're doing is basically just adding here. This is gonna be the panic service, and then this is gonna be the response service, and then we have an event loop here. That is what's gonna do is like it's gonna do next, and it's gonna process the body. It's gonna process the body, and then it's gonna call this basically a structure that we have created around your function. Is gonna send the body process to this structure, and every single layer is gonna act on it. Some of the layers are not gonna do anything with the body, but we'll see in a minute that you can actually add your own layers here and do whatever you want with the body. And some layers are gonna act with the response of this function. This is
So,
gonna create
hey,
the response.
David, so in the middle
Yeah.
there, you add your own layer. Is there an option, or would it be possible to like interject commonalities like parsing, request query or parameters or query? I mean, if you had like reusable functionality you wanted to share across an entire set of lambdas, would that be something you could interject there?
Yep. I'll show you in a minute how to do it. So basically, these response and panic functions are not going to do anything with this process body. They're just going to forward it inside the layers, right? And then it's just going to write to your function. And your function is the one that's going to do something. And then with this response, the panic layer and the response layer are going to do something, right? So like, let's say that your function crashes, right? So we have the panic layer here, and it's gonna capture your crash, and it's gonna be like, well, I wanna be nice, and I'm gonna return a response. So it's gonna transform your crash into a error structure, and it's gonna pass it down again to the response layer, and the response layer is gonna be like, oh, you just wanna return this to Lambda, or I'm just gonna send it to the API, right? And again, like you can also add your own layers here later, which is something that other runtimes cannot let you do. Is like after we return something to Lambda, you actually can also execute code, your own code, which I want to give you a demo because I think it's very interesting part of this project, right? So basically, at the end of the day, what we're doing with this tower service is that like you have your function, you can wrap your function with services just for your own logic. But then if you want to extend the runtime itself, you can create more layers, more tower service layers to extend the runtime itself beyond just extending your Lambda function. I don't know if that's super clear, but yeah, feel free to ask any questions. If you have any, I'm just gonna wake up this tiny computer again. Okay. I don't want to miss anything I have in my notes. Okay. All right. And let me show you what's possible to do with this. I know that this code here, like, it's a little bit daunting because it has multiple enums and it's fairly hard to understand. But basically, when I can give you the information, is like this call function is gonna be the runtime is gonna involve this call function. And then basically, as I was saying, this call function is just gonna call the inner layer. So it's gonna go, this call function is just gonna call the inner layer, and this call function is gonna call the inner layer, and so on and so forth. And what it allows you to do here is like, well, when there's the inner layer has completed its work, all the inner layers have completed its work, I can do something with the response, right? And in this case, what this layer does is this, it's basically just gonna use the HTTP client to send the response to Lambda. So this layer is basically gonna do this here, right? Once every single layer has completed their work, I just wanna return the response to Lambda. And then if we look into the panic layer too, for example, just go here, under catch panic service. It's fairly similar where the call function is basically calling the inner layer, whatever it is, and then if there is a panic, I'm just gonna catch it, and then it's gonna transform it into a data that then the next layer can use. So I'm gonna try to extend. We're talking about call stars. Call this call star. So what I'm gonna do with this quick demo is like I'm just gonna inject a new layer into the runtime that is just gonna tell me if my function is starting new or not, right? Let's see if we can do this quickly. So I'm just gonna call this power store layer. And this is basically what I'm gonna recreate is all this structure, hopefully in a shorter amount of time, just to show you how it works. And then I'm gonna have a struct that's gonna be a call store service. This call store service needs to be generic, and then it's gonna have a service inside, and it's gonna have a call store. It's gonna be a put, right? So this service is basically gonna be the wrapper that we were just talking about around here. The uppermost, the layer up here, right? And this is gonna be a tower service. So we need to implement the tower interface here. This implement service. Yeah, there it is. Thank you, Amazon Q. Save. I think it's not still not smart enough to. Oh, I think I know what's going on. We need to add some dependencies. Give me just a second. So we're gonna add our in project as dependencies to this. It's gonna be a tower service. Yeah, why not? Give me everything. This is not quite right, but tower service. Let me check my notes for a second. It's future. I don't want this future. I'm gonna remove it. This is gonna be a Lambda invocation. I'm gonna create my own feature, and we'll see why in a second. All the start feature. This is not gonna compile for now, but you'll see. I'm just gonna remove this. Yeah, this already, if you're not familiar with how features work, basically it's just a call that the Tokyo is doing to make sure to wait until this feature is ready to be executed. So I'm just gonna forward the request to the inner layer to see if the feature inside is ready to be executed. And then here is what I'm just gonna do here for now. Since this is mutable, I can say color star is gonna be true, false. After the first request, I don't. I'm just gonna log it. Color star. Oops. Yeah, cool. So basically, what I just want to log is like, is there a color star? Right. Something very simple. And then I'm just gonna create a feature. This feature is gonna be a generic. And it's gonna have a feature inside. Right. So this feature is basically what we're gonna return as a response to this call. And for now, we're not gonna do anything with it. Let's see. First, our feature is gonna be feature. Yeah. Feature this response. Okay, we need generic for this. This is gonna be our S. This is gonna be a tower service. And the request here is gonna be a Lambda invocation. And then the response is just gonna be nothing. So what I'm creating here is basically this basic layer structure, and I'm saying that the layers inside are still gonna receive this Lambda invocation object, and then what I want them to return to give me back is gonna be nothing basically. Um, okay, now it's when it's starting to complain about compiling things. Okay. I'll start feature. This is not a feature because it doesn't implement the feature trait, which we can implement in a second. So this just now implement standard feature. Gonna implement what's missing. The output is just gonna be whatever the output of the previous feature is. I don't care about the output. And here Paul is basically what is waiting for this feature to complete. And then here we need to pin this in project. And we need to pin this, be able to access it in project. Okay. Okay, so we're using this. And this is a lot of boilerplate that you probably don't need to understand, but this is basically how you create these layers. What else are we missing here? Okay. We basically are missing still a couple of things, how we're gonna use this layer in our runtime and how we're gonna return this feature. And this feature, basically what it's gonna do, we're just gonna ask ready. It's just gonna say, I'm gonna wait until this is ready. And this is basically feature call. Yeah, you're good at this, Amazon Q. And then what I'm gonna do here is just gonna return this. Ready. With this inside. Let's see. Try. Let's see what we're missing. Project. Maybe that's gonna make it work. Okay. It's gonna make it work. Type output associated implementation without the body. Yeah, because we need to declare that it's a feature. Come on, compiler. You can do it. Let me just check the notes again. Let's put it up. It's important to see what happens. Okay, what happened is this standard library. That's not used. Standard games and context. Okay. Implement feature. I don't remember why that's not compiling right now, but basically what we're gonna do here at the end of the day is the inner layer is gonna give us a response in the type of feature, and what we just want to do is publish the feature. We're gonna wrap that feature into another feature, That's just gonna wait for things. And then we need to initialize this service. And to initialize this service, what we're gonna do is we're gonna implement a tower layer. With this, the service is going to be a call star service, which we just created. We want to do this generic, so it's going to be generic, and the inner is just going to be a generic thing, which is basically a service, and the call star is going to be true. So basically, this is initializing the service. Parameter yes. Now this one. Patient. All right. We're almost there. Okay, we have tower service. We have the login. Now we need to find out why this is complaining. Pin project, pin a pin. That's fine. So type the body product type. Yes, and that's correct. What's the future? Future is the future. Okay, this looks kind of correct. Yeah. Well, let's complete this. What I think about why that's complaining. So now what we need to do, basically, if we want to use this layer, is that we can initialize the runtime directly. So you can initialize the runtime directly yourself, and then do layers, call start layer. Then we're also gonna add the layer, use the layer. Oops. Yes. So basically what we did here is that we implemented this new layer that basically should tell us like whether it's something that's a call star or not. I'm not completely sure what this. Let me just compile it. Let's see if I can get a hint on why that's complaining right now. Probably something silly that I missed. Under test, under poll. That's ready. Then here we have a call start feature. Use the type as feature. Probably not right now, like that's complaining. If anyone wants to guess, I'm all ears. Okay, let's see. if I try to put
Maybe it's the syntax type output equal to instead of
oh
calling.
yeah. Jeez. Thank you, Sadat. Sadat is one of my coworkers. Everyone. I knew it was something silly. Compile it again.
It's good to see I'm not the only one. Those are hard to see.
Yeah.
Ben, can you sing us a song while this compiles?
Yeah, but the
Okay, 30
compiler
days.
is actually more interesting.
And I'm just gonna deploy it. Just straight to production. Without any testing.
That's how we do it, right?
Yeah.
It would be better if it was Friday, but I'll take it on a Thursday.
Yeah. And again, this was going back to the beginning. This was a very simple Lambda function that basically receives a command in the payload and it just returns something, right? So what I can do here, I think I can possibly, okay, yeah, cargo Lambda invoke. I'm just gonna send this JSON document. I test with this code all the time, so I have sample codes for everything. And what this is doing is basically just returning, right? So this is working. So now let's see what the log looks like. We can do one of the logs. This is a shortcut that I have for the AWS CLI. Sample start. Okay. So we got here call star seed. You can see false, false, false. Basically saying like, well, the function was already initialized, so it will only print true in the first invocation, right? But then again, going back to this concept of layers, you can do things before the request and after. So now what we implemented here is like we were just printing something before actually going all the way to the function. But we can also do things after, which would be here. And something silly that I like to do here is that I'm just gonna panic. So we can always get a call star. Why not? Everyone likes call stars, right? I've heard people like not like call stars. So basically what's going to happen here, going back to these layers, is that after I return a response to Lambda, so the function is going to continue working correctly, and it's going to give me responses, I'm going to panic. And what's going to happen is that because I'm panicking, Lambda is not going to reuse my sandbox. So it's going to create a new sandbox every single time. Or that's the theory. So let me deploy it again. Okay, so we can still invoke the function and it just works normally, right? Like I'm getting the response, so like everything really works as expected in the function. And now if we go to the logs, what you can see here is like every single function is panicking. And we should see, no, actually, I forgot to do something. All false. Oh, that's correct. Huh. Okay, so the function is panicking. Environment variable, but the call is still saying that's a call star, which should say that it's not a call star anymore, right? Call star true, call star false. Yeah. Sorry. These are the things about doing demo lives. And we're going to have just 2 minutes for any last minute questions that you all have, because I'm going to wrap up with here as soon as this compiles and we can deploy it and we can see how bad our total stores are going to be. Okay, let's call it again a few times. And for those who missed, what happened was that, like, I was basically setting call store to false before logging it. So obviously it's always going to be call store false. But now if we see the logs again, you can see that call store is always true, right? Because it's basically just panicking all the time, and Lambda is provisioning a new sandbox. So if you want to make a very inefficient Lambda function that always starts with a new sandbox, which I don't recommend, by the way, you can use this trick with the Rust runtime, where you can add your own layers and you end up with being able to do this, right? So just as a recap of this whole hour, basically we'll be diving into the runtime. There are many other things that we can talk about here, like extensions or HTTP, but at the end of the day, all work with the same principles. For example, the Lambda HTTP grade is basically a tower service that wraps around your function and translates the incoming events into HTTP requests. And it doesn't really do anything else beyond that, because we built the whole runtime with this concept of extensibility. So it has given us a very powerful paradigm of, like, well, as long as you can wrap something into a service, you can do many things, right? And as you can see here in the Lambda HTTP grade, what we have is basically a service that takes the request that comes from Lambda and it turns it into a HTTP request object, and it gives it to your Lambda functions, right? So we're not really reinventing anything, and Tower gives us all these powerful constructs to be able to do basically anything we want around either your code or even inside of them. And with that, I think we are almost at the time. We have a couple of minutes for questions, but I think if you have any questions, now is your time, or we can also chat in Discord. I'm in the Discord channel if anyone wants to follow the conversation again. Thank you.
Well, thank you, Dave. That was fantastic. It was like just the right amount of detail with some really cool insight into what you guys were thinking when you put the whole runtime together. And like I said at the beginning, as a Lambda and Rust developer, super appreciative of all the work. And thank you for taking time. I have like a lot of questions, but I'll like do them on Discord. So like if anybody else wants to ask one or two, go for it.
I just want to say I really appreciate all the work on this in Cargo Lambda. It makes it really nice to be able to use Rust and Lambda together. Thank you.
Yep.
We were secretly hoping that like we were going to convert Andres from TypeScript after this call. So that was the real whole point of this entire.
The insights of the runtime are not the best example to convert someone to TypeScript to Rust, to be honest.
David, do you have a question?
Yeah. How is your adoption? I know that I think I might have even been on your team at one point. Are you Amplify hosting or?
Yeah.
Okay. Yeah. So I was on that team. So I remember that we were mostly Node and Java at the time. How has been your adoption now that you've built this runtime? Are you seeing some success here? A lot of teams jumping on board due to the better TP99 latency.
I want to say that, like, I'm not the only one that built the runtime. Like, there are actually other people internally contributing to it. And before me, the runtime existed before me. I just I came in and I basically took over. Yeah, there are a lot of people using it internally at Amazon and externally. The repository is fairly active. Especially, we have a lot of contributions from people improving the event support, because it's one of the most tricky parts of, like, services in AWS implement new events that Lambda can process, and then we don't support them yet. or they add things or they remove things. Most of the contributions, actually, and the ones that I really appreciate the most are from people that just come in and just give us information about those changes, which are not always super easy to discover. But it's fairly adopted. I know Ben uses it. I know companies that use it. A lot of our customers at AWS and use it, and even they also contribute to the runtime itself. But I think it was in 2023 that Lambda announced the telemetry support for extensions, and someone that works at the company that uses the runtime implemented it and gave it to us. Like it was even the day that it was launched, they had been partnering with AWS, and they did all the work, and they just contributed the code back to us. All this layering system that I'm talking about for the runtime was also contributed by someone in the community, and I basically put a document explaining why I would like to have this layering system and how I would envision it building it, and then someone from the community went and basically implemented that idea.
Well, I think the extension area is where all these outside companies are excited because they're trying to put their little layer into your Lambda and they don't want to have a lot of overhead. So I think this is
Yep.
a perfect use case. I was just actually wondering the scope of what people have built. Have they actually built something quite substantial? Are people running more than kind of a control plane? Are they running actual data planes on this or not? Do you know?
I've seen many different apps. I've seen fairly large applications running Rust. I've seen very small things running Lambda. It's also because AWS integrates so many events into Lambda that it's actually very easy to use for pretty much anything that is latency sensitive. You want to process something very quickly. As Daryl was mentioned, like using Cargo Lambda also helps you a lot to get it started and deploy and whatnot. You just saw that how I just deployed from my CLI up to production. So there are people using it in really like all areas of all the scopes, like very big applications and also like very small things that people use to process data.
Yeah,
Okay,
as I say,
thank you.
we used Cargo. Previous customer, I helped them with like an IAM and security piece that's like 8 Lambdas, but it's like in critical path, and it uses this company called Memento as well that's for caching of permissions. So yeah, running with the Rust runtime, and it works fantastic. Really fantastic. Yeah, thank you again, David. I mean, really cool.
Mhm.
Like again, like the community's great and the repo is fantastic, and you guys are super welcoming over there, and we appreciate you jumping on and doing this. I'm not Alan. Alan would have kept us to time. I let us run over.
Yeah. All right.
Thanks, David. Have
Thank
a
you,
great
folks.
day.
It was a pleasure. You too.
Good seeing you guys.